Hey, welcome everyone. This is our lecture 10th of revising chemistry under 10 minute challenge. This is our next chapter of physical chemistry, that is electrochemistry. What does electrochemistry means? The branch of science that deals with the study of electrical energy and chemical energy is said to be electrochemistry. It has many applications in electrolysis, energy producing cells, etc. Now basically understand about electrolyte. Electrolyte are those ions in pure or produce ion after dissolution which conducts electricity either in fused state or in dissolved state. Here are two types of electrical conductors. First one is metallic or electronics conductor, where the current flows due to the movement of electron primarily, and second one is electrolytic conductor, where current flows due to the movement of ion majority. In metallic conductor, no such physical or chemical changes occur in the process, whereas in electrolytic conductor, ions are either oxidized or reduced at electrodes. Both metallic and electrolytic conductors follows Ohm's law, but metallic conductors does not follow Faraday's law. For metallic conductors, conductance is inversely proportional to temperature, and for electrolytic conductors, conductance is directly proportional to temperature. What does electrolysis mean? It is the process of decomposition of electrolyte at electrode by the passage of electric current is said to be electrolysis. The apparatus used for electrolysis is said to be electrolytic cell. Now here are two types of conductivity. First one is equivalent conductivity and second one is molar conductivity. Equivalent conductivity is represented by A equivalent and molar conductivity is represented by mu m. Unit of equivalent conductivity is Siemens centimeter square and equivalent weight inverse. The both conductivity increases with increase in dilution, and the unit of molar conductivity is Siemens centimeter square per mole inverse. Now let's move on to the Faraday's law of electrolysis. In 1834, Michael Faraday put forward the two laws of electrolysis known as Faraday's laws of electrolysis first and second. First law simply states that the amount of substance discharged, deposited or liberated at an electrode is directly proportional to the total quantity of electricity passed through it. Mathematically, W is directly proportional to Q. We added Z, which is electrochemical equivalence. Now, for any change or redox reaction, if Mn plus ion gets n electron and changes or reduces up to m, then n Faradays is required for 1 mole of m. The charge required to reduce 1 mole of aluminium 3 plus ion to aluminium at solid state is 3 Faradays, where 1 Faradays equals 96,500 coulombs. Faraday's laws of electrolysis states that mass deposited in electrolytes is directly proportional to the chemical equivalence, that is W is directly proportional to E. What is E? E is the chemical equivalence. Downside, we can simply state that weight upon equivalent weight equals constant. That was the super trick. And for electrolytic cells, weight is to equivalent weight at cathode equals weight is to equivalent weight as anode. Now you can refer these 6 formulas for calculating weight deposited at electrodes. Now the most commonly used metal for electrolysis or electrolytic cell is silver, copper, zinc, gold, magnesium and aluminum, which shows this type of variable oxidation state and having their respective molecular weights. Special one-liners from Faraday's laws of electrolysis is electrochemical equivalence, that is Z, and chemical equivalence, that is E, are two different things. One coulomb equals reciprocal of 1 electron, which equals 6 multiplied by 10 raised to power 18 electrons. 1 Faraday's equals 96,500 coulombs. For 1 Faraday deposit 1 mole for monovalent electrons, that is sodium, potassium. 1 Faraday deposits half mole of divalent elements, that is calcium, magnesium, etc. Faraday deposits 1/3 mole of trivalent elements, that is ammonium, etc. Electrode potential is the potential arrived at electrolytic double layer of cell, which arises due to the tendency of metal to oxidize or get reduced. If we calculate the value of electrode potential at standard condition, that is 25 degrees centigrade at 1 molar condition, it is said to be standard electrode potential. The factor affecting electrode potential are nature and concentration of electrode used. We cannot measure the single electrode potential as it does not complete the circuit. That's why we need a reference electrode. Most widely used primary reference electrode is SHE, that is standard hydrogen electrode, which is formed by passing hydrogen gas at standard condition using platinum foil as electrode. It has the standard potential of 0 volts. The reason of standard hydrogen electrode is it is not portable. The platinum foil used at electrolyte gets easily poisoned, and the hassle for managing the standard condition is high. That's why we use secondary reference electrode, that is standard calomel electrode, which is consist of the paste of calomel mercury and saturated KCl. It has the standard potential of 0.34 volts. What is salt bridge? This type of inverted U-shaped glass tube is said to be salt bridge, which completes the circuit and which maintains the electrical neutrality. It is inverted U-shaped glass tube filled with solution of inert electrolyte, then does not react with Daniell cell or ZnCu cell. The standard chemical reaction is Cu2 plus ion reacts with Zn to give Zn2 plus ion and Cu, where Cu gets reduced and Zn get oxidized. The cell notation is Zn slash. This slash is the slash is referring the phase transition between Zn to Zn plus plus ion. 2 bar refers the salt bridge. Standard electrode potential of Daniell cell is 1.1 volts. Now the second one is CuAg cell. The cell reaction is Cu reacts with silver to give Cu2 plus ion and reducing the silver. The standard electrode potential of CuAg cell or copper silver cell is 0.46 volts. Lee-Chancellor cell is primary cells. If the E0 of cell is positive, that means the reaction is spontaneous. If equilibrium is attained, then E0 of cell equals 0. Now here is electrochemical series, where the elements highlighted by green color have negative standard reduction potential. They are good reducing agent, as Li is the best reducing agent, and the elements highlighted by pink color are good oxidizing agent. They have positive standard reduction potential. We go from top to bottom or negative to positive in electrochemical series. The standard reduction potential increases, the reducing power of the elements get decreased and oxidizing power gets increased. The metal which lie above in electrochemical series can displace metal from its salt which lie below in electrochemical series.